Hello, myself Akanksha Thorat from VIT University, Chennai. Now I am explaining the Linux kernel architecture. First of all, we understand what is the actual Linux kernel. Linux kernel is the core component of the any operating system. We can call it as the heart of the operating system. It is a monolithic kernel, that is, the Linux kernel is a monolithic Unix like computer OS kernel. The Linux OS is based on this kernel and deployed on both the traditional computer system such as personal computers and servers. The Linux kernel was created in 1991 by the Linus Torvalds for its personal use. This is the picture of the Linus Torvalds. Now we can see the architecture of the Linux kernel. This image shows the clear architecture of the Linux kernel. Linux kernel architecture is divided into two layers: user space and the kernel space. In this space, the user applications are executed. In this user space, GNU-C library is also available. This provides a system call interface that connects the kernel and provide mechanism to transition between user space applications and the kernels. Now this is the kernel space. In this space, Linux kernel is exists. It is also divided into three levels. At the top is the system call interface, which implement the basic functions such as read and write. Below that, there is a kernel code. It is also called as the architecture independent kernel code. This code is based to all the processor architecture supported by the Linux. The next is the properties of the Linux kernel. Kernel is divided into number of subsystems. Linux can also be considered as a monolithic because it lumps all the basic services into the kernel. This is the differ from microkernel architecture because it provides basic services such as communication, I/O, and memory and process management, and more basic services. Next, we see the function of the Linux kernel. This image shows all the functionality of the Linux kernel. First is the system call, second is the process management, third memory management, fourth file system, fifth device control, and sixth networking. Now let's discuss about the system call interface. It is the thin layer that perform functions called from user space into the kernel. You can find the system calls interface implementation in ./linux/kernel as well as architecture independent portion in ./linux/arch. The next is the process management. The kernel is in charge of creating and destroying process and handling their connection to the outside world, that is the input output. Communication among different processes is also handled by the kernel. The scheduler, which controls how process shares the CPU, is the part of the process management. The next is the memory management. This is the another important resource managed by the kernel. Then next is the file system. Linux is heavily based on the file system concept. Almost everything in a Linux can be treated as a file. Kernel builds the structured file system on top of the unstructured hardware. It is also support multiple file system type. For example, disks may be formatted with the Linux standard ext3 file system, the commonly used FAT file system. The next is the device control. Kernel must have embedded the code called device drivers for every peripheral devices connected to the system. The last is the networking. Networking must be managed by the operating system because most network operations are not specific to a process. Incoming packets are a synchronous event. The packet must be collected, identified, and dispatched before a process takes care of them. The system is in charge of delivering data packet across program and network interfaces, and it must control the execution of a program according to their network activity. Additionally, all the routing and the address resolution issues are implemented within the kernel. This is all about the Linux kernel architecture, their properties and functionalities. Thank you.